Hello everyone and welcome to another video of VV Clones. In the last video of PepCoding Level 1 that we had made, we had solved this sliding window maximum question, which I think is a pretty difficult question, right? So what I'm thinking now is that I'm not feeling motivated to solve further questions. So if I'm not feeling motivated to solve the questions, what I'm trying to do is that every day I'm trying to revise the questions that I've already solved, but in a new way. So this will give me some motivation that I already have solved these questions, but solving them again without having a look at them, that will motivate me. So we will try to solve this stacks module that we had again, right? So the first question, let's start the revision. So this is about the recursion. So in the recursion series also, I'm not feeling motivated to do the next video. So that's where I am revising the old questions and revising the old questions and having a broader perspective. Having a broader perspective, like I am, what do you mean by having a broader perspective? Having a broader perspective is that solving the same question that we have using 2-3 approaches. So if you see here print array, I have solved it using 2-3 approaches. So yeah, I will try to have an open mind for this stacks and queues module also, and we'll try to solve it using different approaches if any I can think of. Let me go back to the Java stacks and queues module. So we had duplicate elements bracket first here, right? So you are given a string expression and the expression is balanced. Like every opening bracket has an closing bracket. That is for sure. But some of the brackets may be extra or needless. Okay. So like these brackets, they are extra or needless. So how did we approach this solution? So what we did was we had this expression, let's say, and what we did was we tried to add the elements of the stock, not the stock, the stack. So we tried to add, so let's go here in paint and let's try to discuss it, how we approach this question. So let's say we had this and we had a stack. Okay, where do I have a stack? How do I create a stack here? So what I tried to do was I tried to push all the elements first. If so, I pushed this first, right? This opening bracket first. Then I pushed A. Then I pushed plus. Then I pushed B. Then I again. So whenever I saw a closing bracket, what I did was I popped all the elements till I saw an opening element, and then I popped the opening element as well. So I popped, popped, and popped the opening element as well, right? So this will keep the stack as empty and then we'll again start filling the stack. So again we'll have plus inserted into the stack, then we'll have open bracket, then one more open bracket, and then we'll have C inserted into the stack, then this plus sign inserted as well as D inserted. Okay, so once we have all these elements inserted and we see an opening bracket, a closing bracket, we pop. We pop till we find an opening bracket and then we pop the opening bracket as well. And this is where the catch we have, right? So before popping, we need to check if the peak, the stack dot peak, does it contain an opening bracket? So before popping, we need to check if the peak is a closing bracket or not, is an opening bracket or not. So if it is an opening bracket, what will happen? If it is an opening bracket, then there are no elements present. There are duplicates bracket present around that, right? So these two brackets have already surrounded C plus D. So checking if the stack.peak has a closing bracket was the catch here. So let's see how we had solved this. Look, this was the duplicates bracket question, right? So mm, or the balance brackets. Yeah, this was the question that we had solved, right? Not the duplicates one. So yeah, so let's try to solve it again. Mm, let's try to have it this way. So we'll try to solve it in a different way now. So I'll use a for loop this time. Let's see. So I'll start from zeroth index of the string to str dot length, right? String dot length, correct? Oh, we have expression exp dot length, and we have length as the method here. So what do we do? Mm, while mm, while stack dot peak first first before peaking we have to check if it stack is empty or not. If stack is not empty, what do we have the stack name? Char stack. Okay. So first we'll have to check if char stack dot is empty. If it is not empty, and char stack dot peak is equals to an closing bracket, then we do what do we do? We do char stack dot pop, right? Right. But before popping once, we'll have to check if the next element is closing bracket or not. So we'll have to check if hashtag dot mm, no, we have to check this here, right? So if char stack is not empty, if string is not empty, so we'll have this condition here, right? Exp dot char at. So we'll have to check if the index at I is equals to a closing bracket. If it is a closing bracket, then we'll have to pop. Okay, if it is a closing bracket, first we'll have to check if we have an opening bracket in the stack. If we already have an opening bracket, then we return invalid, right? So we have this invalid flag. Invalid is equals to true. So let's assume for this case that invalid is false. Invalid is false. Okay. Is valid. Oh, is valid. So is valid if true. Then we'll make it false. Is valid. I thought it was invalid. Sorry, my bad. So we'll check if we have a closing bracket. And once we check if we have a closing bracket and after that immediately we have an opening bracket, then it is not a valid and then we break from this while statement. Otherwise we do hashtag dot pop, and once we do hashtag dot pop while okay, till what do we have to do hashtag dot pop? while char stack dot caret is equals to this, then we'll have to do perform this. Otherwise, we'll have to do char stack dot push exp dot caret I. Okay, so if we have this, let's try to evaluate. So once so for every element we are pushing, that is for sure, right? But we have to pop here once more. But let's see about that. So I think we can have an if condition here, and then if char stack dot peak, if char stack dot I, if this closing bracket, then we can see char stack dot peak. If expression dot caret I is bracket, we can check if peak, and if not, then we can while we find an closing bracket while char stack dot peak is not equal to an opening bracket till we do char stack dot pop, and then we again do once more char stack dot pop, right? So is valid if true. First we assume that it is valid, then we check if the expression is ending with a closing bracket, then we immediately check if it is the element in the char stack is the topmost element. If it is an opening bracket, is valid is false, and then we break. Otherwise, what do? We keep on popping. We keep on popping till we find where till char stack is not equal to this, and then we again do pop once more to pop this opening bracket, and we for each and every element we do char stack. We do char stack dot push. Yes, right. Let's try to run it. We'll to enter this. So is valid. So it will be false, right? Oh, is valid if true. Surprisingly. How did we get is valid true? Okay, let's run it once more. So we are supplying which char stack. We have this expression dot length dot exp dot caret. If it is a closing bracket, then we have performing this operation. Char stack dot peak equals to a closing bracket, an opening bracket, then is valid is false. It is invalid, right? Otherwise, we do while char stack dot peak is not equals to closing bracket, till then we do char stack dot pop. Then we do char stack dot push. Okay, so let's suppose we have, let's try to debug this. So we enter this into the stack, then this, and then we see an closing bracket. Once we see a closing bracket, this loop and this condition will execute, and we check if the element is not, the element is B on the top of the stack. So we pop till we find this one, and then we pop this also, and then we insert caret. Yeah, that's what we do, right? We don't. So I think we need to have if condition, right? Else condition here. So that's what we are missing. Let's try to run it. Yeah, so this is invalid. Let's try another one. This is valid, right? So we had missed the else condition here. So if we don't have the element as the closing bracket, then only we push. Otherwise we pop, right? Yeah, so that is where the condition was missing. Let's try to run it once again with a simple test case like this, which should give us is valid as false. Yes, it does. Yeah. So the next question that we solved was this duplicate brackets is the one that we solved one now, right? The next one was a balance brackets. So in this question, what we did was we were given an expression and we had to find if the expression was valid or not. So there were different cases that needed to be considered, right? So let's see this duplicate brackets question. So what we did was for every opening bracket we used to push, and for every closing bracket we used to see if we have a closing and opening bracket or not. If we did not have an opening bracket, then we used to return is valid as false, and then we used to print it here and then we used to return. But let's try to find some other approach to solve this question. So let's see, we have this one, right? So what I'm thinking of an approach is I can, for every opening bracket I have a counter variable which is initialized to 0. For every opening bracket I increment 1, and for every closing bracket I decrement 1. So for this opening bracket I increment 1, so this becomes 2, then decrement 1 again becomes 1. But I will have to have counters for each and every bracket, like a counter for a square bracket, a counter for an mm, and then we also have the condition here, right? So here what we saw was that this is not a valid scenario, right? Because the closing brackets, if you see the square brackets, the square bracket should have closed before this, right? So the counter, I don't think the counter method will work because we'll have, so this use case specifically will not work there, right? Where we have equal number of brackets, but we have them at different positions. So I think the approach that we have used, right, that is the best approach that we have. So what is the approach? Let's discuss that. So the approach that we did was, let me erase this. This is the question that we had. So what we did was for every opening bracket we used to insert, right? We used to insert an element. So we'll insert this, then we'll insert this, then we don't insert A or B. Then for closing bracket we pop this. Then for the opening bracket again we insert for a closing bracket. No, again we insert for an opening bracket, which is this round bracket. Then we pop because of this bracket. Then we again insert this opening bracket, then we again pop this closing bracket, then we pop this one, right, and then we pop this one. So this was a valid. So if the stack is empty at last, it is a valid scenario, right? So this is what we need to check. So this is what we used to check. If the stack is valid, we return true, right? Otherwise, we'll have those different conditions, right? So we had three different conditions. So here, the first condition was that we had an extra. What was wrong in this? Let's see. Yeah, so we had an extra element at the last, right? We had an extra. Okay, what is wrong? Yeah, so the brackets are mismatched here, right? So if the brackets are mismatched, then while popping this one, this element will not find its right partner. So after popping this, it will try to the next element to pop was this, right? Yeah. So this is where we'll have to handle the condition. So if we had to, first we'll have to check if stack is empty or not, and we have to check if stack.peak is an closing square bracket. If it is a closing square bracket, then we do pop. Otherwise, we set this valid flag as false, which is what we are doing here, and then we just print it. So this is how we solve this question. And we had another scenario where we had an extra element in the extra element, right? So in this, uh, we had an extra starting bracket, the extra square bracket, opening bracket. So this is where the stack wasn't empty, and if the stack is not empty, we return false, right? And in this last scenario, what we had misplaced the order, right? So this opening bracket, okay, so this opening bracket didn't have, so we had an extra closing bracket. So yeah, so we just needed to handle the different scenarios that we had. So yeah, so this is how we had solved the first two questions of the stack module, right? So in the first question, we saw that if we encounter a closing bracket, first we need to check if the stack's pop element, which we get using stack.peak, is it an opening bracket? So if it is an opening bracket, then there are no elements between uh, between the closing bracket and an opening bracket. So that is where we'll be having duplicate brackets, and we set the is valid to false, and then we just break. And if it is not the element, then we keep on popping. We keep on popping till we find an closing bracket. Once we find a closing bracket, we pop that closing bracket as well. And if the stack element is not, if the expressions character is not a closing bracket, then we just do char stack dot push. Just insert into the char stack area. That was the first question, and the next question was that finding the duplicate brackets, right? So we there are different scenarios which we saw here, right? So in this was the scenario which had balanced brackets, but in this scenario we had the positions of the brackets changed, right? So we need to handle those. So for every opening bracket we used to insert, and for every closing bracket we used to pop. But while popping we had to make sure that uh, first we had to do a stack.peak. We had to do stack.peak, and we had to check if the element that we are peaking, like if we had this closing bracket, then this closing bracket should have its partner, which is this opening bracket, as the stack.peak. If not, then we set it as invalid, and we just print it and return. And there were other scenarios as well, right? So if stack is empty, then we have to return true. Otherwise, if we had some extra elements, then we used to return false. So this is how we had solved the first two questions of the stack module. So I think they were pretty new to me, and I was facing some issues recollecting those. So I thought of revising all these stack modules, and I had hit a roadblocker solving this. Like this was a not that much difficult, but this involved having two, three concepts that we had learned. Sliding window maximum problem. Like this question involved recollecting this next greater element and the next smaller elements question and having some more logic around it, right? So I thought of revising all the questions that we had done, and we have revised two questions in this video, balance bracket and duplicate brackets. In the next video, we'll continue revising some of the more questions that we had. And once we revise all the questions till the sliding window maximum, we will then continue the video series further. So that was all for this video. See you guys in the next one. Thank you.